Is the boiling point of 1 drop of water the same as the boiling point of a gallon of water? These are the sorts of things we'll consider when we investigate the difference between an extensive and an intensive property. We'll figure out what the difference between those two things are, and we'll find examples of each. We'll also take just a brief moment to understand two little terms that show up occasionally: crystalline substances versus amorphous substances. This is Screencast 3.5. Okay, let's look at some different properties, and we'll ask ourselves if it's an extensive property or an intensive property. The key to understanding the difference is in the words themselves. Extensive, as in extent dependent. It's amount dependent, meaning the property will change if there's more of that stuff. An intensive property is amount independent. It doesn't matter how much you have, the property stays the same. Does the melting point of a substance depend on how much you have? It does not. One good crystal should do it. And so it's an intensive property. Mass. Well, obviously if you have more, the mass increases. Therefore, that's an extensive property. Get it? Density. Well, if you have more helium, will it have a different density? Truth is, no. The density is still the same. Less than 1 gram per liter, essentially. Much less. Does it matter how much glass you have in terms of how much it will bend light? If the shape is the same, no. It's an intensive property also. Now, toxicity is an interesting one. That's an extensive property. More heroin is more likely to kill you. Crystalline amorphous. Crystalline simply means shiny. Amorphous means not shiny. So, diamonds are crystalline. Aspirin or other sorts of white powder, typically baking soda, for example, are not shiny. They are amorphous. Note that a crystalline substance is almost always of a higher purity than an amorphous substance. So, chemists love to see crystals if they're looking for a pure substance. This is Screencast 3.5.